Alright, welcome back. This is Lesson 8, solving equations with variables on both sides. The goal today is when we solve these types of equations is to collect all the variable terms in one side of the equation. In order to do this, we use the same properties of equality and inverse operations that we've been using this past few weeks. So here's a equation, the 7k equals 4k plus 15. Notice we have a variable on both sides of the equal sign. So we're going to use the same properties that we've been using to try and move the variables so they're all on one side. Now it doesn't matter if we put them all to the right or all to the left, but we want them all on one side. So in order to move this, I'm going to move the 4k to the left-hand side. In order to do that, this is a positive 4k, so I want to make a negative 4k. So I'm going to have to do that to both sides to make it go away on the right hand side. So I'm going to subtract 4k from both sides. So 7k plus a negative 4k is 3k. And over here 4k plus 15 minus 4k, this 4k and this minus 4k, those are additive inverses, so they become 0. So I'm left with just 15. Here I would use the multiplicative inverse. Multiply by 1/3. It's the same thing as dividing by 3. When I divide by 3, that becomes 1, leaving me with just k. And over here, 15 divided by 3 equals 5. So all the same properties we've been using all along are what we're going to continue to use today, trying to isolate the variables onto one side of an equation. So let's practice a few more of these. Whenever you're in one of these situations where you have a variable on both sides, it's really a smart idea to try and simplify both sides first before you start moving anything around. So let's look at this example on the left, the solve for k example. Here I have 3 times the quantity 1 minus 2k equals 2k minus 5. So again, I have a variable on both sides of this equation. I'm going to focus on the left-hand side first and try to simplify that as much as I can. If I notice the right-hand side is already simplified, I can't combine like terms or anything on that side. So I'm going to focus on the left-hand side first. So this is going to be our distributive property. I'm going to have to distribute this 3 to both the 1 and the minus 2k. So it's going to be a 3 times 1, and here I like to do this also. Always make this positive like that. And that's going to be 3 times a negative 2k, so 3 times negative 2k. And then I have equals 2k minus 5. So let me simplify this. 3 times 1 is 3, plus 3 times negative 2k is negative 6k, equals 2k minus 5. Now it doesn't really matter which side we move the variables to, but I think one of the good strategies here is to try and always make your variables be positive, the coefficient in front to be positive. In order to do that, I'm going to want to move this negative 6k. And by move, I mean add 6k to both sides. If I add 6k, then on the right-hand side, the k's will become positive. I could just as easily have subtracted 2k from this side, both sides, but then negative 6k and a negative 2k is going to keep my coefficient over here negative. And let's try it. It doesn't matter, but it's just a little bit easier if we keep things positive. So to do that, I'm going to add 6k to both sides. Add 6k, add 6k. What happens here is I'm left with 3 on this side, because negative 6k plus 6k is 0. On this side I have 2k plus 6k, so that's 8k minus 5. Now let's use the additive inverse to get rid of this negative 5. To do so, I'm going to add 5 to both sides. So 3 plus 5 is 8, equals 8k. Negative 5 plus 5 is 0. So I have 8 equals 8k. Now I would use the multiplicative inverse, otherwise just dividing by 8. And 8 divided by 8 is 1k, and 8 divided by 8, it's not 0 here. Remember, anything over itself is 1. That's a really big mistake a lot of kids make. All right, let's look at this one on the right. This one's a giant mess. Um, Again, we want to just really focus on trying to simplify as much as we can. So I'm going to work from left to right, but it really does not matter which way you work. So I'd like to first change some of these minus signs to negative signs. So I have this negative 2 here, that's okay, plus a negative 2 here. I'm going to plus a negative b, and what the heck, I might as well do it over here too, plus a negative 5b. Okay, so first thing I notice is that again I have some sort of distribution going on the left hand side, and since multiplication, okay, which is what distribution is, comes before addition and subtraction in my order of operations, I have to do that first. So I'm going to distribute this negative 2 to that 1 and this negative 2 to that negative b. So what's left is, let me rewrite this, I have this negative 2 out front, now I have plus, I have this negative 2 times 1 plus this negative 2 times negative b. And on the right hand side, I'm going to go ahead and simplify this right now too. So I'm going to have, I notice I have a negative 5b and a 2b. Those are like terms. So I have 3 plus a negative 3b left. Let me go ahead and clean this up. So that says negative 2 plus a negative 2 times 1 is negative 2 plus negative 2 times negative b. Anytime you have a negative times negative, that's a positive. So that's positive 2b equals 3 plus a negative 3b. Nothing's changed on the right side. Now I can start to really clean this up again. So let's see, I have negative 2 plus a negative 2. Well, that's negative 4. So I have negative 4 plus 2b equals 3 plus negative 3b. Looking at this now, again, I want to try and get my variables all on one side, collect them all to one side. Again, it does not matter if I move them to the right or the left, but my personal opinion is try to make everything positive. Well, that means that I usually want to attack the negative coefficient with the variable. So over here on the right, I have this negative 3b. So I want to add 3b to both sides to make that go away and bring the 3b to the other side. So let's add 3b to both sides. So that leaves me with this negative 4. 2b plus 3b is 5b, positive, plus 5b. And over here, this negative 3b and this positive 3b, those are additive inverses. That becomes 0. So I'm just left with 3. So since I moved the variables to the left, I should move all of the constants, all of the numbers without variables, over to the other side. So to do that, I'm going to use the additive inverse once again. To move this negative 4, I need to add 4 to both sides. Add 4, add 4. That tells me I have 5b equals 3 plus 4 is 7. Now I would use the multiplicative inverse at this point, or just divide by 5 to get the b by itself. And that tells me I have b equal to 7/5 or 1.4. So we have these two different special cases whenever we have variables on both sides of an equation. The first type of special case is called an identity. It's where we'll have an infinite amount of solutions. Now remember, whenever you have a variable in an equation, you can choose whatever you want to put in for that variable and see if it works. But if you choose a number for x, you have to be consistent throughout the rest of that equation for that same variable. And what we'll see here is no matter what number that we pick for x, it will always be the case that this thing is true. So let's see this in action. So on the left-hand side, I have 10x plus 12, and I can't do anything with that. But on the right-hand side, again, let's think about simplifying. So I have this 2 times 5x plus 6. Well, if I take that and I say I distribute 2 times 5x and 2 times 6, the left-hand side hasn't changed. The right-hand side now says 2 times 5x and 2 times 6. So cleaning this up, the left-hand side still has not changed. And the right-hand side, 2 times 5x is 10x, and 2 times 6 is 12. You might be able to already see that right now it says 10x plus 12 equals 10x plus 12. Well, those are exactly the same, so of course they're going to be equal. But let's see what happens when we start to solve for this. I want to try to move my variables to one side. It doesn't matter. I'm going to bring my x's to the left side, and I'll bring my constants to the right side. So the first thing I'm going to do is move this 10x that's on the right. It is a positive 10x, so I need to subtract 10x because those are additive inverses. Subtract 10x from both sides, keep the equation balanced. 10x minus 10x is 0, and 10x minus 10x is 0. So I'm left with just 12 equals 12. I don't even have a variable anymore. Okay, so sometimes that happens. What if instead I decided to move the 12 first? Let's see what happens. So instead of moving the 10x, I'm going to move the 12. So I'm going to move this 12 that's over here. I'm going to move that to the right-hand side. So let me subtract 12 from both sides. And that leaves me with 10x, 12 minus 12 is 0, equals 10x, and 12 minus 12 is 0. Okay, so if I want to get my variable by itself or move the variable to one side, I would just at this point subtract 10x from both sides. And this is weird. 10x minus 10x is 0 equals 10x minus 10x is 0. But again, notice 0 does equal 0. This is a true statement. 0 does equal 0. It doesn't tell me anything about my x, but it does tell me that this is a true statement. That's because this is what we call an identity. No matter what number I put in for x, I'm always going to get this thing to work out to where it says something equals something, and that's a true statement. So that's called an identity, and it has infinite solutions. That will happen sometimes. The other thing that will happen is we're on the right-hand side here where we'll have no solutions. The empty set, it's called. Okay, and they have these curly little brackets with nothing in it. That stands for the empty set. There's nothing, no solution can possibly make this work. In other words, no matter what number I put in for x, consistently throughout this entire equation over here, nothing will make this become true. And let's see. So let's work on simplifying. On the right-hand side, I can simplify. I do have like terms over here. But why don't we use the commutative property first and move this 6 and 9x. So I have negative 8x. The commutative property, I can move the 9x here and the 6 here, equals negative 17 plus x. Nothing's happened on the right. So negative 8x plus 9x, when I combine those, that leaves me with just x plus 6. Over here I have negative 17 plus x. Okay, so let's move the x's to one side and see what happens. Well, I'm going to subtract an x from this side and subtract an x from this side. So x minus x is 0, so that leaves me with just 6. And over here, x minus x is 0, which leaves me with just negative 17. And on this planet, 6 does not equal negative 17. This is not true, not equal. Okay, so let's see what would happen if I had done this a little bit different. what happens if instead of moving the x's, at first I move the constants. So why don't I add 17 to both sides first here? Let's see. Add 17, add 17. So this will tell me I have x 6 plus 17 is 23 equals 17, negative 17 plus 17 is 0, so this equals x. Okay, now let's move our variables all to one side, collect them, so I need to subtract an x from both sides. That tells me I have 23 because x minus x is 0. I have 23 left, and over here x minus x is 0. 23 equals 0, again, not on this planet, so that's not true. Notice over here, it did say 0 equals 0. That's a true statement. Over here, this says 23 equals 0, and I don't think that's a true statement at all. So again, this is what we call the empty set. There's no solution for x that's going to make this equation work. All right, finally for the next class, if you could please just copy and complete this graphic organizer that's down at the bottom of this page. It should only take you a minute or two to copy it down. In each of the boxes, create and solve an example of an equation that has the indicated number of solutions. So you're going to create this whole picture down here in the bottom of the slide. And over here where it says no solution, you're going to come up with an equation and show me that it has no solution. Over where it says one solution, you're going to come up with an equation that has variables on both sides again and show me it has one solution. And infinite solutions, you're going to do the same thing there. Come up with an equation and show me that it has an infinite amount of solutions. And that is your ticket in the door tomorrow. We will see you next class.